Many times we have had this moment happen to us, and we are tired of it. We enjoy a good jam session while we are running. So we wanted to come up with a way to solve this problem. Our question that we would like to pose in this project and throughout this video is it possible to charge an iPod from arm motion while running? We will provide our results at the end of the video. For our calculations of turns that our coil would need for the inductive coil turned out to be a huge number. We found this number by knowing that an inductive coil with 1100 turns would give us a peak-to-peak voltage of 10 millivolts. So we knew we wanted about 5 volts out, so we multiplied both by 500 and got 550,000 turns. This is a huge amount, and we weren't sure if that was exactly right, so we checked our math with the EMF formula. It was the same amount, so we started turning the coil and watching the counter go up.
Another main component of our circuit was the magnets to put inside our inductor. We chose to use the most powerful magnets we could find, while still keeping them small enough that it would not be cumbersome to the runner. We also needed some type of spring on either end of the magnets, so there was a smooth motion while running. The springs would also give a more consistent sine wave voltage. When a magnet passes through a coil of wire, it causes current to flow through the wires. This in turn means that there is a voltage difference between the two ends of the coil. Because the movement of the runner makes the magnet oscillate between the two ends of the coil, an AC voltage is produced. We need to change this to a DC voltage to be able to charge an iPod. Diodes are components that only let current flow through them in one direction. By putting 4 diodes in this formation, we make a rectifier, which forces the current to flow towards the output. This changes the AC current into a constant DC current. A regulator regulates the output voltage to ensure we get the 5 volts necessary to charge the iPod. Some of the voltage is dissipated within the regulator, so we needed to make sure we had about 7 volts going in to get the required 5 volts out.
Since our voltage was 350 millivolts peak to peak, we realized that we must build a step-up transformer. We knew we needed about 7 volts out, and so to find the turns we divided 7 volts by 350 millivolts to find that the turns ratio was 1 to 20. From this we built our transformer. Now, when building your transformer, you want to be careful about how you build it. When we built ours, it acted as a high-pass filter, so we didn't receive any voltage out because we were at such a low frequency. This caused us to buy a transformer chip that was 1 to 20 from Coilcraft. The high-pass filter comes from a high total resistance connected to our shaker before the transformer. One thing you might try is connecting another resistor in parallel with the shaker to bring down that resistance before going through your built transformer. In conclusion, we discovered that the power we receive out, even though the voltage is not enough to charge our iPod. However, there is no lost hope. There are 3 ways we can improve our design. 1 is to add more coils to the inductive coil. 2 is to add more magnets to those that are passing through the coil. And 3 is to find a way to make the magnets move faster.